Solve each radical equation. In our example to the left, we have square root of 4x plus 1 is equal to 5. When solving these radical equations, it's a good idea to have your radical term on one side of the equation and all other terms on the other. To eliminate a square root radical, you square both sides of your equation. The square root of 4x plus 1, when squared, you remove the radical, and that leaves 4x plus 1. Two fives have a product of 25. Solving for x, we subtract 1 from both sides. 4x equals 24, and then we divide by 4. X equals 6. 4 times 6 is 24, plus 1 is 25. Square root of 25 is 5, so that is satisfied. The example to the right, if we add 10 to both sides of the equation, we isolate the radical term, and it's equal to 10. Squaring both sides, the square root of 5x squared is 5x. 10 squared is 100. Divide both sides by 5, and x equals 20. 5 times 20 is 100. Square root of 100 is 10, minus 10 is 0. That equation is satisfied. When you move to a cube root equation, this first example, we have cube root of 12 minus x equals 3. As long as you have the radical term isolated from the rest of the equation like this, you can cube both sides to remove a cube root radical. The cube root and the cube will undo each other, so that leaves 12 minus x. 3 3's have a product of 27. Be careful not to call that 9. 3 3's have a product of 27. Subtract 12 from both sides, negative x equals 15. Divide or multiply both sides by negative 1, and you get x equals negative 15. If you wanted to check, 12 minus negative 15 is 27. Cube root of 27 is 3. The example to the right, we have 4 plus the cube root of 2x minus 9 equals 0. Our radical term is not isolated, so let's subtract 4 on both sides. Cube root of 2x minus 9 is equal to negative 4. Now we can work on removing the radical. Cube both sides. The cube root of 2x minus 9 cubed is 2x minus 9. 3 negative 4's have a product of negative 64. Solving for x, we add 9 to both sides. 2x equals negative 55. Divide both sides by 2, and x equals negative 55 halves. Square root of x plus 8 equals x plus 2. The radical term is isolated from all the other terms. Square both sides. Square root of x plus 8 squared is x plus 8. On the right side, you have to be very careful. X plus 2 squared, over here in the blue, x plus 2 quantity squared, that's 2 x plus 2's multiplied together. X times x times 2, so our first two terms are from distributing x. Then we switch over and multiply by 2. 2 times x plus 2 times 2. That's another 2x plus 4. Combining like terms, that's x squared plus 4x plus 4. Come back over to your problem. Underneath here, x plus 2 quantity squared is x squared plus 4x plus 4. Now, because we have a quadratic term, and this is a quadratic equation at this point of the problem, I'm going to bring all terms over to the x squared side. In order to do that, I'm going to subtract an x from both sides and subtract an 8 from both sides. That zeroes out the left side. leaving x squared plus 3x minus 4 equals 0. This can be factored with x minus 1 times x plus 4. Negative 1 plus 4 has a sum of 3 and a product of negative 4. X minus 1 is equal to 0 when x equals 1. X plus 4 is equal to 0 when x equals negative 4. In the original problem, if we check x equals 1, that gives a square root of 1 plus 8, which is 9. On the right side, we have 1 plus 2, which is 3. Square root of 9 is equal to 3. That's true. We keep that answer. When we check negative 4, the square root of negative 4 plus 8 does not equal negative 4 plus 2. The square root of 4 is 2. That does not equal negative 2. That's false. This answer we do not get to keep. It is an extraneous solution, and sometimes those happen when you square both sides of an equation. Let's switch over to solving rational equations. Let's solve 7 equals 19 over x plus 6 over x squared. In order to eliminate the fractions, we need to multiply all terms by enough to get an x and an x squared to cancel. If we multiply all terms by x squared, that gives us 7 times x squared, which is 7x squared. 19 over x times x squared, we can cancel an x from top and bottom, and that leaves 19x. And then our last term, x squareds completely cancel one another, leaving plus 6. Because of the quadratic term, I'm going to subtract 19 x's and a 6 from both sides. That gets one side of my equation to 0. This equation is actually factorable, but if you don't feel comfortable factoring, remember you can always fall back on the quadratic formula. A is 7, B is negative 19, C is negative 6. As a reminder, here's your quadratic formula. Substitute in A, B, and C very carefully. Negative 19, negative 19, that's positive 19, plus or minus the square root, negative 19 squared minus 4 times 7 times negative 6. Put these values in your calculator. You should find the discriminant of 529. The square root of 529 is 23. The denominator is 14. And then to get our answers, we will use the plus sign. 19 plus 23, that's 42. Divided by 14 is 3. Using the minus sign, 19 minus 23 is negative 4. Divided by 14 reduces to negative 2/7. The only answer you would have to eliminate if you get it at the end would be 0, because 0 and 0 squared would create 0 denominators, and that equation would not be defined. But 3 and negative 2/7 are okay because they do not create 0 denominators. In our second example, we have x plus 2 over 13 equals x plus 2 over x plus 11. When you have two fractions that are set equal to one another, a over b equals c over d, you can cross multiply, and that saves you a little bit of trouble of having to get a common denominator to multiply by. X plus 2 times x plus 11 equals 13 times x plus 2. X plus 2 times x plus 11. Starting with x, we have x squared plus 11x. Then we move to 2x plus 22 when you distribute it. The right side is 13x plus 26. 11x and 2x combine for a 13x. So at this point, we have x squared plus 13x plus 22 is equal to 13x plus 26. Because of the x squared term, I'm going to bring everything to the left side of the equation, When I do that, I need to subtract 13 x's and subtract 26. That leaves us x squared. These two terms go to 0, and these two terms go to minus 4. X squared minus 4 is a difference of two squares, so that factors as x plus 2 times x minus 2. Each factor set equal to 0 results in the answers of -2 and +2. Go back to the original problem. The only value of x we couldn't use would be -11, and that's because if x is -11, we get a 0 denominator, resulting in an undefined. And then finally, we have our last equation we're going to look at is 4 over x minus 5/3 equals x over 6. We need to multiply by just enough so that x, 3, and 6 will get canceled. If we use 6x, the first denominator cancels into the x's, and that leaves 24. The x's cancel. 4 times 6 is 24. The second term, 3 goes into 6x, 2x times, 5 times 2x is 10x. And then finally on the far right side, our 6's cancel, leaving x times x, which is x squared. I'm going to bring -10x over with addition, and I'm going to bring 24 over with subtraction. Always go opposites when you cross the equals. This one is very tempting to factor with 6 and 4, but you got to be careful. In order to get a sum of 10 and a product of -24, you actually have to factor with x plus 12 and x minus 2. 12 and -2 have a sum of 10 and a product of -24. The first factor is equal to 0 when x equals -12. The second factor is equal to 0 when x equals 2. The only number you would have to watch out for would be 0 itself, because if x is 0, you have an undefined term. -12 and 2 are okay. They don't cause a 0 denominator.